Well, thanks for joining us. I know we've also got a special guest for today's presentation. So I am going to do some introductions. Give me 1 second. All right. So thanks to everyone for joining today's presentation, Real-Time Application Monitoring for Ionic Apps with Sentry. My name is Rachel and I'm on the marketing team here, and I'll be your moderator for today's event. And before getting started on the presentation, I'd like to go over some housekeeping notes for you. First, this webinar is being recorded, so we'll send you an email to a link with the recording and slides after the event is finished, and you'll be able to revisit this content later on. The presentation will be about 45 to 50 minutes, and we'll use that remaining time to answer your questions that you submit during the event. So feel free to submit questions just by clicking on the Q&A icon on your screen, and we'll get to as many as we can after the event. And then if you have any technical issues or concerns, you can send me a message directly in that Q&A box as well. I'll be monitoring that throughout the event, and I'll be able to help you directly. So to introduce today's presenters, I've got our very own Mike Hardington, and he's a developer advocate here at Ionic. Sorry, guys. And then actually joining us from Sentry is a special guest, Neil Manvar. He's a solutions engineering manager at Sentry. So thank you both for being here. I'm going to pass it over to them for the presentation.
All right. Thank you, Rachel. We're going to take a quick look first at Ionic. We know that a lot of people here might be familiar with Ionic, might be already in the Ionic ecosystem. But for those who are coming to us from Sentry that are not familiar with Ionic or have not used Ionic before, or maybe have heard of it but aren't quite sure what it is, let's dive into that first. So what is Ionic? So Ionic is a UI framework for building cross-platform apps, meaning that you are building apps for iOS, native Android, and also deploying to the web as something like progressive web apps or a general website. Now, Ionic does this by shipping a collection of components and integrations with different frameworks, so that way, as you build out your app, you can get a native look and feel of your app that feels at home for these native platforms. Now, Ionic is being used by huge number of people. Can't really give you the exact numbers, but what we know is that over 10% of the apps inside of the iOS App Store are using Ionic, and on Google Play the stats are close to about 20%. If we do some fake math and try to average that out all together, about 10% or so between the entire app stores, both iOS and Google Play, are Ionic apps. So if you actually go to appfigures.com, you can actually get a nice little breakdown of some of the top SDKs, and Ionic's right up in there. But more importantly, Ionic is a community, is adopted by huge amounts of users in our community. So if you are a company looking to hire people to do Ionic, chances are that you are going to find someone who has some Ionic experience wherever you are in the world. Now, Ionic is pretty unique in the component and UI toolkit space in that it is built as standalone web components. Meaning, if you don't want to use a framework, you want to just roll your own kind of tooling, your own ecosystem, your own kind of web page and your own infrastructure, you can still use Ionic's components and import them as you need them inside of your app. Meaning that if you don't need a framework, we can still work with you. We do also integrate with Angular, React, and we just recently announced our new beta release for Ionic Vue. So if you're using any of the big 3 frameworks out there, you can use Ionic with that and get the nice component design and animations and transitions that we bring to the table. Now, being a component UI toolkit, we try not to step over frameworks and dictate how things should be done. So every time you go ahead and build a Ionic app, if you're using something with Angular, you're going to be using the Angular CLI and the familiar tooling that comes with that framework. Same thing for React, and same thing for Vue. So we give you this nice set of components and then kind of get out of your way. So everything feels very familiar and integrates well with whatever tool chain that you choose to work with. Now, let's ask the question, why do we need Ionic? Why do we need cross-platform components? What does that even mean? Or what problem are we trying to solve? So the problem that we're trying to solve here is that if you're trying to build a mobile app, just in general, it's quite difficult. Building for mobile is really, really hard, come to find out. If you want to ship, say, a native iOS app and a native Android app, well, first off, you need to figure out, okay, what's going to make my app unique? What's going to make it special? I'm going to need to design and customize my app's look and feel for both of these platforms, and then also the web. Okay, well, then once we get past the design phase and actually get into implementation and the coding, now we're dealing with a separate project for iOS, a separate project for Android, a separate project for the web. It's not great. Okay, well, what if I don't know iOS development? Well, I either have to hire someone who does, or I have to learn it myself. And maybe that's not something I want to spend my time doing. Same thing goes for Android. Building for these platforms requires a lot of knowledge that not everyone has, nor do people really want to know. And then I mentioned it before, but what about the web? What about progressive web apps? How do we deploy something that can fit all of these different deployment targets and reduce the amount of code that we have to write? So Ionic, it provides all the necessary pieces and tools to give you the way the mechanism to build high quality apps, all with web technologies. And let's kind of look at a sample project that we have here. I have an app that I've been working on called the Ionic Conference app. It's just a sample kitchen sink app that we've been working on. If you go to, I think the URL is ionic-ng-comp-app.web.app. I'll post the URLs in the slide later. But this is an example app that we have deployed actually to the web as a progressive web app. So this is installed on my machine. We've seen the taskbar. I have the conference app icon right there. I get access to things like dark mode, so my app feels more at home to my system preferences. I can come in here and I can start navigating to, say, the different session schedules. So, okay, well, breakfast is probably my favorite time of the day. So let's keep a tab on that. Let's go check out speakers. We can come over here, see the different speakers, see who we have presenting at this hypothetical conference. And Carl Kitten looks like a pretty interesting person. Get some links to the different social medias. Let's go back to our schedule. Between this app and this setup, we're maintaining separate navigation context, feeling right at home to a native platform. We can also come over to our About page, start to integrate with some of our overlay components like pop over here. We also have things like our alerts and date pickers, which people can use to add features and add more data inputs into their app. And if we need to have a tutorial phase, we can also just start showing a tutorial with some gesture-driven slides to get people acquainted with our app. So we can go back to our app, and we still have the navigation working as you would expect. So this is a sample of an Ionic app. And we can post the links later to the live demo. We can also deploy this app to the app stores using Ionic and shipping it to iOS and to Android. So back to the slides, we've kind of looked at that sample project, So that way you can give you a taste of what kind of features Ionic has to offer. We're not going to spend too much time going on the basics of Ionic because building the app is only a small portion of it. Once we have that app built, what's next? How can we ensure that our app, it was working great on my machine when I was developing it? How can we make sure that it's working well when I deploy it to the stores? Well, we can actually use tools like Sentry to help gain insight into our apps and figure out when there is an error, or if there is an error, where is it happening, what's the culprit, and how does this actually, how can we go about resolving this and fixing our app for our users? So at this point, I want to have a presentation from Neil Manvar from Sentry. I'll play that right now. Neil was nice enough to join us for this webinar, so I'll let the video play.
Thank you for the warm welcome. My name is Neil Manvar. I'm a Solutions Engineering Manager for Sentry, and I'm here today to show you how Sentry and Ionic play together. But before we get into that, just want to describe where Sentry fits in the tool chain of monitoring. So we have our systems level. Is my hardware good? That's mostly for your admin ops. We have APM. How's my application behaving within the systems? Mostly backend and operational oriented. And then logging, right? We all have applications that output to the logs, but we don't want to sift through those. It's like finding a needle through a haystack, especially when an error happens. And that's why Sentry exists. So as an Ionic developer, right, you're writing JavaScript, you're committing code, it's being deployed. Sentry is what's going to tell you that it's broken and exactly what's broken on what line of code, what devices are affected, even the commit that caused it. And I'm stealing my own thunder here, which I'll show. We've also gotten into performance monitoring for developers. And what we mean by this is telling you that your application is not only broken, but it's also slow on the front end side of things. And these are potential optimizations that you can make, or it's slow on these API calls or database queries on the back end side. But today we're going to be concentrating on the error monitoring portion of it for Ionic. But Sentry, as we know it, consists of 5 pillars. As I mentioned, we're going to focus on the core being error monitoring. We've gotten into performance monitoring. Release health means we're able to tell you what are the crash-free sessions are, the release adoptions, and more or less metrics around your release so you can understand as you're putting code out there how it's behaving for your audiences in a release point of view. Discover being our analytics engine and query engine where you can slice and dice any of this data. I'll showcase that as well. And ecosystem being the integration. So you'll see me be alerted in Slack, even pulling up the GitHub commit. We have a long list of integrations to make sure you're aware of these errors, issues, and you're able to get issue tracking going and getting the commit integration, as I mentioned as well. So Sentry works in all the different stacks and frameworks as we have SDKs for them. So I'm going to go ahead and concentrate on Ionic here and web and mobile in regards to that. But whether you're developing a front end, back end, IoT, etc., Sentry is what's going to tell you that your application is broken via an SDK that you install to surface that information. And since we're at the application layer, we will be surfacing information and data and errors from all of the various environments. So whether it's automation running or a manual test running, and that's causing errors, you want to know about that as soon as possible, or you're pushing out a build to a subset of your audiences, staging a canary, you want to know about that, or if production is borked in regards to a feature or overall, I'm sure you want to get that addressed as well. So if you don't have Sentry, and I'll emphasize this quickly and kind of showcase this and move on to with Sentry as well, but you might not know that errors are happening on your mobile devices, on your browsers, etc. Your application might not be working, you're not accepting money. If you're lucky, they'll file into support and then go through an internal escalation process. Finding the root cause or engineer that caused this might take days, and eventually you'll probably have to look at a log and eventually fix it. And the log, as I mentioned, has information that may or may not be relevant. And we all know in the world of JavaScript, we minify the JavaScript before it hits the client-side devices, and we see a stack trace that's completely obfuscated that doesn't really mean anything for us. And so if you're using Sentry, we will show you all of this, the clean stack trace, as I mentioned, the commit that caused this. I'm going to show this all in action for Ionic, but this is just a quick sneak peek. So let's get right into it. I'm going to go through the documentation and the setup steps first. And then I will showcase all of this in my application and then go through the workflow, triggering the error, and then gathering all the details. So first, in terms of installation, let's go and head over to the Sentry documentation. Go ahead and search for Ionic. And here we see the documentation and the setup steps. So first thing is npm install the package and go ahead and add the platforms. And quick little note here is without the Ionic wrapper. And go ahead and generate those source maps so that we can deobfuscate those stack traces, meaning we can get those clean stack traces and detect similar errors and surface the information and clean stack traces as you would want them. So that's how you're going to go ahead and do this right over here. And lastly is the instrumentation within the code. So go ahead and import the package that was just installed. And what you'll do is called Sentry init with the key key that's given to you when you create a project on the Sentry end. So here's the DSN key, and we want that to go to sentry.io and the project ID. And what's happening here is it's instrumenting on to the error handler and providing you SDK to get information up to us. And since we're in the Ionic Angular land, go ahead and set up that error handler and specify it as a provider in your app module TS. So I'm going to go ahead and showcase all of this in my app right here. So starting from the top, package.json, we can see the package right here. And then going into app module, right here, you can see I am importing it and then setting it up. I also want to know what versions of my applications these errors are coming from. That's why I've specified release. This is also necessary in source mapping, which I'll get into in a moment. And here is the error handler, which is more or less just shooting it up to Sentry. And we want to specify the error handler as a provider right over here. So that's all that's necessary. My app is pretty simple. It's actually just an app that throws a bunch of errors by me causing them. So anytime I click a button, it'll run through these functions over here to cause that error. So let's go ahead and deploy this and get this triggered and go tackle it from there. So here's my application. And just quick, if you weren't using Sentry, what would happen is you probably wouldn't know about these until you do, and then have to reproduce it, then have to deal with this log and go from there. But since I am using Sentry, what's going to happen, and you can see these coming in live right now, is I've been alerted that these errors are happening. My application is broken, so stop developing, stop playing racquetball or whatever it is that you're doing, and go ahead and address these. So I'm going to go ahead and just click into one of these, and let's take a deeper look here. So now we're within Sentry, specifically the issue view, and we're going to see the who, what, when, where, why of all of this. So you can see it's a type error, not a function error. So it looks like we're calling something that doesn't quite exist. I'll get to that in a moment, but it happened 12 times, affecting 2 users. Started happening about 4 hours ago. Today, looks like, introduced in this release, last seen in this release. We can hook into any issue trackers such as Jira if necessary. I'm going to go skip that for now. And any tags introduced into our system will produce a heat map. So from within here, I can understand it's happening on a bunch of different browsers. More importantly, it's happening on browsers as well as Android. And on these variety of releases. So you can just see in those 15 seconds, I went and scrolled down and got an understanding of the impact, exactly what's going on here. And we can iterate through all 12 of these events here in the main pane, see exactly what was going on with each and every one of these. And what we would have seen in the log was actually a minified stack trace. And what we've done here is deobfuscated it. So we see it happen on app component.ts, line 42. On this line of code, we can hop into any of these frames, see exactly what was going on. We can see the full stack traces. We'll only show you the relevant ones, just so you don't get overwhelmed. And we'll even show you what happened in the application prior to hitting the error. So you see it was loaded up. It was then a click resulted in an error, which bubbled up as an exception. And that's what constitutes this event right here. And then any other information we want to surface, we'll go ahead and do so as well. So to recap, here we see this type error, we see all the details, the stack trace, the breadcrumbs, the aggregate information, and my favorite feature is we will even show you the commit that caused it. So what we're seeing here is that Neil Manvar introduced this error via this commit right over here, and this likely broke this, and Neil Manvar is the best developer equipped to fight this fire. Because you don't want someone else debugging your code, trying to make sense of it, and then trying to go about fixing it when you can get it in the relevant developer's hands who has the best idea. And with the maximum context that Sentry provides here, we can then roll forward, roll backwards via an educated decision here. So just to summarize what we've seen here, so going back to the slides, is I've showcased how to install the SDK in Ionic. And then we were then alerted, and I'll go into the platform and showcase all of this. We evaluated all of the context that Sentry provided from within our UI, and then even found out the commit that caused it so we could get that developer to commit this and then stabilize. So I'm gonna go ahead and showcase this in Android as well, just to kind of show what we would see there. But here I'm just causing errors on the Android side of things, and I should see these come in on Slack, letting me know that something is broken and I can address, and that's exactly what we see here. So we'll click this one. We can see it's coming in from an Android SDK or a device if it was real, and back to the JavaScript, and which takes us to the function that caused this. The other thing y'all might be wondering is how is the alerting working here? So if we go to our alerts, we can then set up any of these alert rules. This is the one that was being triggered, which is every time an error happens. And if you have a production app, you probably don't want to do something like that. You might want to do something like, hey, this interval, as well as every time if it's first seen. But more or less, you can take in any of the event attributes, and there's a very flexible alerting system that consists of conditions and actions. So here, the condition being when it occurs, or a frequency-based one, as I was alluding to earlier. And here we want the action to be a Slack notification going out to this workspace, and we can surface any additional tags as well, or we could do PagerDuty, email, etc. We have two different types of alerts. So what you just saw there was an issue alert, but if you wanted to set up something that was more liberal based on any of the information coming in, you could set a metric alert. So here I could then run a query against any of the subset of events here, and then set an according limit here. So if I wanted to set an Android specific alert, for example, it would look something like this for not just the issue, but all of these errors. So Android experience is getting bad or something. So in terms of this working, we covered the SDK. Y'all might be wondering about the source mapping as well. So how did that happen? So to kind of showcase this, I'm going to actually show you how the Sentry ingestion engine works. So what happened behind the scenes here is this came in with the minified stack trace, and we had set the release information as well and uploaded the source maps to this release. So a minified stack trace came in, or an event with a minified stack trace came in with this release, and the artifacts, the source maps, were uploaded, and we applied them on ingestion to get that clean stack trace, which we then used to aggregate all the similar errors as well. And we have a little CLI tool to help you with this. So I've this behind the scenes. So here it is. I'm just uploading the source map. So this would happen at build time. And you can see producing those source maps by just passing this flag in. And once the output, being the source maps, have been created, go ahead and upload those to Sentry. The CLI tool releases the organization of Sentry that you created, the project, and the version. Upload those source maps and the location to them. So you can see here in my deployed targets, I'm doing this for web, Android, and iOS, and uploading those so that we get all the context that we would need to fix this. As I mentioned, I was going to cover Discover as well. So now that we're sending traffic into Sentry from our Ionic apps, we might want to get more answers to this outside of them having this error and it happened this many times and here's the stack trace and here's a commit. So let's go ahead and assemble a couple different queries to help us answer some different questions. The first one being, I want to know the distribution of all of the events or errors across all of the different device families. So let me go ahead and assemble a query here. Family, I want the overall number as well as the number of unique issues as well as the unique users impacted as well. I'm going to go ahead and query that, narrow in on this data set right here. Or actually, I'll zoom out here, and you can see based on the count that, I'm having a bunch from Mac. We can go ahead and exclude this one as I was testing earlier. From Mac, Android, iPhone, and even this device over here. An additional one that you might want to do, which is just also very interesting as a developer, is let's say, what is my worst file name in terms of errors, right? So I could go ahead and do that, as well as once again do user impact there as well. So here we go, and you can go ahead and see, bam, these are my worst file names, or if we only wanted to do this for a certain project, we could go ahead and do that as well. So here, I've just gone and selected Ionic Webinar so that we can go ahead and see the events that we were messing around with here. And you can see my app components TS is the major culprit. So just to now wrap it up, what I've shown is how we've implemented the SDK, gotten the source maps up. We configured alerts so that we were in the know regarding our application being broken. Got into Sentry to figure out the who, what, when, where, why, all of that context from the in-app. And then even figuring out the commit that caused it, routing this issue to the right developer who can then fix and stabilize, roll forward, roll backwards, and we can go back to playing racquetball. And how does this all work? We showcase this, but Sentry is an event ingestion engine. We have the SDK sending us events, which is errors or transactions. And then on the downstream side, we have the integrations being alerting, Slack, PagerDuty, et cetera, source code management being GitHub, GitLabs, Bitbucket, et cetera, and then issue tracking, Jira, and whatnot. There's other integrations as well, but those are the major ones. So takeaway, you have an Ionic app, you want to know when it's broken. Sentry tells you exactly what's up there, the line of it, exactly the line that it happened on, all the context, the aggregate information, so you can understand the impact, getting to the commit that caused it so that you can fix it. All right, thank you.
All right, thank you for that overview, Neil. Let's bring back my video. Awesome. Cool. So that was a great overview of Sentry and everything that it has to offer. And the example that we looked at inside of that video was covering Angular and Cordova. I think it's important to have those two covered. We know a lot of people who have heard of Ionic or are currently using Ionic are probably using Cordova still. But I think we also should take a look at something a little bit different. I wanted to take a look and put together an example for Ionic and React. And I actually wanted to use our new native runtime, Capacitor. So for those who don't know what Capacitor is a runtime and library for shipping your web apps as native apps to the App Store and also to the web as progressive web apps. It sounds very similar to the goals that Ionic tries to fulfill, but it has a very distinct purpose in that Ionic offers the components and Capacitor provides the app shell. A great way to think of it is Capacitor is the electron in the sense that it gives you the shell, it gives you the API to call certain device features. Now, the APIs and tools that it exposes try to utilize web standards where possible. So for instance, if you wanted to call the camera or call some geolocation, it's going to use those native features on the web and then opt out to use the native platform features in, say, iOS or Android. And then finally, to make sure that this all comes together pretty well and make sure that there's no hiccups in the tooling and the platform that you're using, Capacitor utilizes native tooling under the hood, so it can bring in things like CocoaPods, native Android libraries to integrate third-party packages into your native project. So let's dive into that and take a look at an Ionic React project set up to use Sentry. So I'm just going to quickly minimize my slides. And I'm going to kind of cheat a little bit because I have some of this set up a bit. But what we have here is our issue board where we should be seeing some incoming issues for our project. Now, our project itself is a fairly typical Ionic React project. Like I said, it utilizes React scripts under the hood, so nothing too fancy there. But what we'll do is we'll just split this out, and we'll set that up right there. So we have our app running right now. All this is doing is just going to throw a bunch of errors and warnings, similar to what Neil's example was showing before. Let's go to not the network tab, but to the console tab. So if, for instance, we threw a decode warning, we'll definitely get an error inside of our app, which is to be expected. We could also throw a syntax error and get that same warning. But if we were to deploy this, we have no way of knowing what these errors are. So let's go over to our app and let's go to the index.tsx for our file, for our project. So I've already installed the necessary dependencies for this, but just to make sure that we have this all set up and ready to go, we're going to come in here and we're going to import everything from the Sentry React package. This is going to give us our way of configuring Sentry for this project. And because we're in a React project, we're going to choose the React package for this. So once we have that put together, we can start configuring Sentry pretty easily. So the next thing that we'll want to do is grab sentry.init, passing in our project configuration. And then this is something that actually tripped me up the very first time, is that we need to specify the release for this. So I'm going to actually borrow a makefile from Neil's example project where we're going to generate a release ID and then pass that in through process.env. So this is how Sentry will know, hey, this batch of code and source maps are associated with this release. So we can do a proper lookup of everything. Now, once that's configured, we do need to do a little bit of hackery to make sure that everything works well. So with Capacitor and the way that it works, we have a nested web server. So all of our projects will get served from a local file server on the native device. On iOS, that's going to point to capacitor://localhost. And on Android, it'll be http://localhost. So we need to account for that when applying our source maps. And one way to do that is to take this little sentry.addGlobalEventProcessor. So anytime Sentry detects an error, we can get the data that is going to send back to Sentry and start to modify it a little bit. Now, all I'm really doing is just stripping out the prefix for capacitor or HTTP localhost inside of our project. And then inside our global event processor, I'm going to actually just go through each frame in the stack trace. And if the frame has a file name property on it, I'm just going to modify that real quickly. And this will strip out the leading protocol and host. So this isn't overly complicated, and the source code for all of this will be available afterwards if you want to look into it. But what we'll do is we'll just save that. And we're going to actually just go ahead and run a build. So first for this, we will just run git add, or well, first, actually, we need to remove the build due to just some quirks on my end. So what I'll do is just run git add, and then commit add Sentry to project, if I can type. So this is great. And then inside of this project, I have this make file, which again, I borrowed from Neil's example project, where all we're doing is just setting up a release process where we will do our config for our version and our release number. We'll do a build, and then we will create a release with Sentry itself, and then associate the following commits with that release. So this is all fairly self-explanatory and covered in depth in Sentry's docs. So definitely take a look at that. The real important part here is this make uploads or upload source maps. Where in this case, because we're a React project, we build to a specific output folder. So we build to the build static JS file. And what we actually want to do is rewrite the URL prefix for all of our source maps to include the static JS extension to this. This is just a little way to make sure that when the errors come in, we can map back the files in the source maps correctly. So with this all set up, let's just come back to our terminal, and we're going to run make deploy. So this will run our React scripts build, which is just running npm build under the hood. It's going to create an optimized production build of our app, which includes source maps out of the box. So nothing really needed there. We will update and analyze our source maps, and everything seems to be working. Now, to make sure that we have this working correctly, let's go to our settings. We'll go to our projects, look at the React project in particular, and then go to the source maps and see we have the commit that we just published a few seconds ago. So with this, we can actually deploy to our devices. We could also deploy to a hosting provider. For instance, if we wanted to deploy to Vercel, we could just run Vercel deploy right now. But we are going to deploy this to our iPhone. So I will run npx cap copy. Now, I already had Capacitor already set up for this project, but if I wanted to set it up from scratch, I could just run npm install at capacitor core and at capacitor CLI, which will give us the CLI tooling and then the core library. And then to integrate Capacitor into a project, we can just run npx cap at cap init, which will create our project configuration, and then npx cap add either iOS or Android for our platform. So we ran cap copy to copy our assets to the iOS project. Let's run npx cap open iOS, and we'll be brought to Xcode. Now, Xcode can be scary for people who have never used it before, but just think of it like iTunes. And instead of playing music, it just builds you apps. Now, we're going to target our running simulator right here, so this won't take too long. We'll just run a quick little native build, and we know that we did that because we just hit the play button. And we're going to come back over to our project overview and make sure that we have the real-time updates already applied. Now, with Sentry already enabled to this project, we should be able to generate some errors just by clicking some random buttons, which we all know will cause an error. And this gives me enough time to get a little sip to soothe my throat. And in case it doesn't pop in right away, you can always do a quick little let's always go to, let's try this one more time. All right, so that doesn't seem to be, that's a demo failure today. I was bound to have one because everything went well in another example, but thankfully I thought ahead and I have a different example already up and running inside of another project. Now this is that same exact set of errors and same exact set of modifying the stack trace file name, but just in an Angular project. So this is still using capacitor under the hood, and we can be sure about that because we see, where was it? This one. Here we go. We can still see that the URL is capacitor localhost tab/tabs. And when we call our range error, we're still getting the source maps popping up, pointing back to the entire stack trace. So this is great. So we know what error that we have in our project, we know where it is, and we can go about fixing it. Let's go back to the slides. Bear with me one moment. Cool. So aside from the one little technical difficulties with the React project, we still have those errors coming into our Angular project, which will also be included in the resources for this webinar. So definitely take a look and play around with it, try to see what is actually, what the actual setup process for this is. So before we head to the Q&A, just some parting thoughts. If you are interested in building for cross-platform, whether you need to target iOS or just need to target a good component library for the web, Ionic is a great choice for this. You can get everything that you need for native development as well as web development. If you want to make sure that your app can stay up to date and stay healthy and keep an eye out for any errors that could pop up here and there, Sentry is a great way to monitor that as well. And if you still want to use cross-platform development, but maybe you don't want to use Ionic, that's totally fine. You could use something like Capacitor, which is independent from any UI library, but still gives you the tools that you need to target cross-platform. So at this time, I'd like to invite Neil back up to the webinar, and I'd love to go over some of your questions. I see a few of them have popped up in the Q&A, so happy to go over them. Okay, so hey Neil, how's it going?
Fantastic.
All right, let's bring up the Q&A. If I can figure out how to do webinars. Cool. We got a few questions coming in. So let's see. Let's go to the first one. So this is actually a good question for you, Neil. Can we get a copy of the source code that you're using to demo Sentry? Someone's already using Sentry in their project, and they're just having a little bit of trouble to get it up to get it working.
Sure thing. So all of the code, Sentry SDKs, the Sentry server, including the examples I wrote, is open source. So my stuff is up there on github.com/sentry-demos. This is the Ionic example, but I will make sure that it's in the follow-up email or any comms going forward. And if you need any help, or I know me and Mike were debugging source maps yesterday, right? Or day before, I can't remember. But write into us. We just want to make sure every developer knows about their application errors so that they can do something about it.
Yeah, there was there's some little, it was a little hiccup on my end, but yeah, Neil was able to help me out and I got it working right away. So yeah, we'll make sure to include a link to the demos. So be on the lookout for the follow-up email. Another great one. Does this detect issues, crashes in the app due to plugin code or just your front-end JavaScript?
Yeah. So with the Cordova library, I believe this would be the JavaScript side, but if you're using any of our Android SDK or iOS SDK, it actually instruments the exception handlers as well as hooks on to the crash handlers as well. So if you do have a hard crash, native crash, it'll also service that and will do symbolication to basically translate those native crash addresses into readable function names so that you can do something. So on the mobile side, if you're using our true SDKs over there, or raw ones, they will instrument to both exceptions, errors, and native crashes.
Yeah, and the example I had, I think I was just using the JavaScript SDK, so that wouldn't detect any app crashes, but there's nothing stopping you from actually implementing the native SDK with Capacitor directly because you still have access to the full project. So that could also be done as well. I didn't do it because I didn't know actually how to simulate a native app crash. I'm not quite sure how to achieve that. I guess I need to go to Stack Overflow and find out.
You gotta do some Stack Overflowing. There's a convenience function within Sentry as well that helps you test it out.
It's good. So that way you guys know how to actually crash native apps.
Yeah, more than you would probably want to know about that.
So cool. A really nice one. I know we see this a lot with certain solutions. Can we use Sentry as a self-hosted solution?
Mm-hmm. So I alluded to this earlier. Sentry is open source. So what we saw and we're messing with today was Sentry.io, which is our multi-tenant SaaS solution. But that being said, you can pull down Sentry. It's just a set of containers. We have a Docker Compose file and get up and running and have your errors shot up into there. And all the feature development is done on our open source repo. So the parity is there as well. So at the end of the day, I know this is getting a little repetitive, but we just want developers to use this and know about their errors, right? Deployment methodology is a different question or conversation. So pull it down, get going, and get up and running.
Sweet.
There's also, free shout out to Sentry. It'd be easier to get started with Sentry.io. That being, we do have a free, I believe, which is what Mike may have been using. So you can just get up and running with a couple clicks and not have to deploy any containers and maintain anything. So that's your choice. Just use it, please.
Yeah, no one wants to deal with apps that can break. So add some sort of error monitoring. Sentry is a great solution for this. This is a good one for Ionic specifically. Does Ionic without a framework work? Is that production ready right now in the migration guide? There's still no info on this. So if you are building Ionic apps and you don't want to use a framework, that is potentially a can of worms. It's a very broad topic to cover. Like you could include different bundlers, different build tools, what have you. So for us to give like a prescribed answer or to give like very detailed instructions on how to do this, it might not necessarily fit every use case. So if you're not going to use a framework, we kind of hope that you have some knowledge that you can bring to this to solve that problem, how to pick your own router, how to pick your own build tools if you need them, etc. So we don't give any instructions here because we kind of hope that you have all that already, and which is why we also encourage people to use a framework if they're going to be building something with, say, a full team. So no answer. You can, but just know that you should also be able to figure out how to do routing, how to do your build process yourself. All right, here's a good Sentry one. What will happen to a report if the user does not have an internet connection?
Good question. So on the Android and iOS thing, what we try to do is we persist the error to disk, and we flush it out when there's an internet connection typically. And all of our SDKs have a transport layer where you can overwrite how you want essentially it to be sent out or persisted or whatever, and modify that behavior. So on the JavaScript side, it'll just try to asynchronously flush it out, and optimistically you can overwrite the transport. On the mobile side of things, where it does have that context of, you might not always have an internet connection available to you, it will persist to disk and then flush out when it's there. In the instance of a native crash on the mobile side, it will try to flush it out on relaunch, because when something crashes, you really don't have many hooks into it.
Awesome. Good to know. I was actually curious about that myself. I was trying to think, like, what happens if there is no internet? Can we override this?
Yeah. Things are pretty generic in a simple setup, but now with mobile and IoT and all these different interfaces and such, we're having to account for a lot of these, right? First, JavaScript was only in the browser. Now look where we are.
Well, I mean, even just like being able to override how the stack traces were sent back to Sentry was just, oh, I didn't know that was possible until I was like started digging into it. I was like, oh, it's cool that you can actually do that. So it's good to know that you can override those behaviors if you need to.
Yep, absolutely.
Custom events, is it possible to log these as well?
Yeah, absolutely. So what we saw in our earlier examples were mostly uncaught errors, right, that bubbled up to the global exception handler. But you might be doing something like try catch, or you might want to, just say Sentry.capture message. This crash happened or something like that, right? Or hit this. Basically, the SDK provides you Sentry.send message and Sentry.capture exception for these scenarios as well. So as part of instrumenting onto the global error handler and shooting any of that event data out, Sentry SDK also provides you a way to interact and get information up explicitly.
Awesome, excellent. Let's see, what else can we? Okay, here's one that someone asked. How would you compare Sentry to, say, some competitors or some other options that are out there? What is the big value prop for Sentry versus something else? Answer this how you will.
Absolutely. So in this example, I'll take this in two facets. So first thing, let's just talk about kind of platform support and breadth. So in a complex, application or modern day application, we have a front end and back end, and typically more components, right? Here we just error monitored the front end, and we got that visibility, which typical error monitoring APM solutions may or may not have the front end visibility part. That's one thing. And then let's say we were communicating with the back end. Sentry, if it was deployed on all of these services, could show you all of this. Hey, this error manifested on the front end, and it's due to this backend, and it's due to this commit, and Neil can fix all of this. And you see how we showed the Sentry demo, and we're able to get to this information. So Sentry is the only one that gets you to the commits, has all the platform supports. You can search our entire data set to find whatever you need. So all of that, plus as a developer, as we're working on all of this open source stuff, Sentry is an open source company as well. But regardless of framework, Sentry will tell you the who, what, when, where, and why, whether it's a native crash, whether it's an error, front end, back end, IoT device, whatnot. And we'll always try to get you that deep context, as you saw earlier, in regards to the aggregation, detecting the similar errors. We didn't show this off explicitly, but Sentry has a great workflow. So we just want to tell you about your errors, get you all the context, get you to roll forward or roll backwards, and get you out. So very friendly developer tool in that sense. Works with all the stacks, giving you all of that visibility, code level monitoring inside of the application, so that you can really get down to the root cause. The commit is typically what answers that.
Awesome. And then I think we've got time for like one last question. And this is an interesting one because I was curious about it when you showed it to me a little bit the other week. Can you talk about the performance monitoring? Like what is it actually doing under the hood other than just watching my app?
Yeah, good question. So when we say performance monitoring, what we want to try to answer, especially for like a front end or a full stack developer, is why is my app slow and where is it slow? So it's going to be the same SDK. It's just a one-line change to ship up transactions into Sentry. So you can think of Sentry as an event ingestion engine, errors and crashes being what we've been talking about so far. Now we're ingesting traces. So think about when a front end is loaded, a page load transaction will be sent to us showing exactly what happened. And then as part of that transaction, it might have gone to the back end saying, hey, I need, all of these things. That then that span links into another transaction. Now we can see it was a slowdown with the database query. Was it because we're not lazy loading something on the front end, or we're doing sync on the front end, etc. And so what we're trying to do is, hey, this was slow. It was on the front end, and there was an error, and this is the whole thing. Or hey, this was slow on the front end to the customer, but because of the back end, and there may or may not have been an error, and we're try catching for looping, and this is a commit to cause an error, and here's the performance impact, and here's the jeopardized experience.
So it's really giving the whole, picture of not only the front end aspect of it, but the back end. Why is something happening? And thinking of it as like an event, like system versus just error tracking, I think really, really sells that point of just like, hey, it knows something happened. Take a look at it. Here's what happened, and here's some related pieces that could be caused by that.
Sure. As well as another thing that we were being asked very often is like, hey, you guys are doing a great job of telling them my app is broken or it's crashed. But to me, when it's slow and a user drives away from it, or or it's slow beyond an SLO or something like that, I want to know about it, and whether there was an error or not, and I want to be able to. So now, if you have a customer that's using your app and they're like, hey, it was slow when I was doing this, I can find that exact transaction and see exactly why it was slow, and then go from there. We no longer wanted it such that, hey, I want to reproduce, give me more details, etc. It's kind of similar with errors, but also do it for the performance side of things, so that the front end developer could get to actually fixing it and going from there.
Awesome. So cool. So we're right around that time where we need to wrap everything up. Thank you all for coming to the webinar. Thank you, Neil, for joining us and giving us an overview of Sentry, and hopefully everyone who attended today was able to find out some information about it. And if you do not have a error tracking system, or you do not have something in your apps, Sentry is a great solution for this. Check it out. We will be sending out a recording of this webinar, as well as the resources we've talked about here. So be on the lookout for that email. Thank you all for coming.